Good morning, ladies and gentlemen. This is Mrs. Avila presenting your lesson for Wednesday, April 29th. Our essential question today is how can the amount of energy absorbed by the Earth's surface change? Today, our lesson is titled Introduction to Energy Entering and Leaving. And we are going to watch the Screencastify videos. I think I have to break it up into two today, going through the lesson. Okay, no fighting. So probably will be two videos. You're going to fill out the lesson 2.1 Intro to Energy Entering and Leaving document. You're going to copy and paste key concepts numbers 6 and 7 into the Unit 7 Key Concepts chapters 2 and 3 document. You will need to have the Screencastify videos, the lesson 2.1 Intro to Energy Entering and Leaving document open, and the Unit 7 Key Concepts chapters 2 and 3 open. I'm doing my lesson. Make sure you press turn in for your lesson 2.1 Intro to Energy Entering and Leaving document. Do not turn in the key concepts assignment, however. You're going to be working on that for a few days. Meme of the day. Meme of the day, quarantine day 21. Okay, you need to stop talking. I have a cat with a dog, and the cat is on top of the dog. Andrew. And it says, I swear to God, if you sniff my butt one more time, and it appears to be choking the dog. Being at home, some of us are on edge. Okay, so going to the lesson for the day. You have to have this document open. Okay, so lesson 2.1, Introduction to Energy Entering and Leaving. Our essential question again, how can the amount of energy absorbed by Earth's surface change? Have this document open and ready to type as you watch the lesson video. Also have the key concepts document open. The research you conducted as a student climatologist has shown that at the same time ice is melting on Earth, carbon dioxide and methane are increasing in the atmosphere. And that results in higher temperatures. But why? Temperature is tied to the amount of energy absorbed by Earth's surface. What can affect absorbed energy? All right, so our unit question is, what causes climate change? Chapter 2 question is, why do temperatures on Earth increase when the amount of carbon dioxide or methane in the Earth system increases? So you have a warm-up. Imagine you are filling a bucket with water, but the bucket has a hole in it. What will happen to the level of the water in the bucket? So, you're not with a bucket of water. Shh. Okay, so you're imagining this. You have to type in, what do you think would happen to the level of water in the bucket? Pause the video if you need more time. All right, in chapter 1, we determine both temperature and energy absorbed by the surface increases when the amount of carbon dioxide or methane increases. Now, here is the chapter 2 question again. Why do temperatures on Earth increase when the amount of carbon dioxide or methane in the Earth system increases? An email has come from the director of the World Climate Institute. From Irene Lee to student climatologist, that's you, regarding your next assignment. The research you have done so far is impressive. Remember, she works for the World Climate Institute. The evidence is strong and it supports the claim that increased carbon dioxide or methane in the atmosphere is correlated with climate change and the increase in ice, or the decrease in ice, To make your explanation stronger, I'd like you to investigate how an increase in carbon dioxide or methane could cause increased temperature. Since we already know that energy absorbed by Earth's surface must be increasing, as a climatologist, the next question is how the amount of energy absorbed by a surface can change. I suggest you look at energy entering and exiting the Earth system, and this will bring you closer to understanding what might be causing climate change. Looking forward to, there goes my mouse, looking forward to learning from your results. Dr. Irene Lee, head climatologist, World Climate Institute. Right, correlated means one thing seems to be related to another thing, generally because they happen at the same time. For instance, increased temperature seems to be related to increased carbon dioxide, or increased carbon dioxide seems to be related to a decrease in ice. So you can think of correlated as this picture right here. Dry, hot, sunny summer weather, causation, ice cream melts, causation, there's sunburn occurs. Yes, you can have that. So you could think of a correlation between melting ice cream and sunburn. Somehow something is related in that process. When things are correlated, it doesn't necessarily mean that one thing caused another thing to happen. Correlations can be good evidence, but they aren't strong enough evidence to prove that one thing causes another thing to happen. Melting ice cream does not cause sunburn. Sunburn does not cause melting ice cream. But something there is related to cause the ice cream to melt and to cause sunburn. Today's investigation question is, how can the amount of energy absorbed by Earth's surface change? In the sim, energy both enters and exits the Earth's system. For the warm-up today, you thought about water entering and leaving a bucket at the same time and what that means about the water level in the bucket. This is similar to energy entering and exit the Earth system. If we know something about energy entering and exiting, we can figure out how the energy in the Earth system might change. So, some definitions that you guys had to write and that we are using today is model, an object, diagram, or computer program that helps us understand something by making it simpler or easier to see. Change, when something becomes different over time. And stability, when something stays mostly the same over time. So I want you to think about the sim model. Okay, here's a screenshot of the sim model. Energy both enters and exits the Earth system. Remember, the yellow arrows represent the energy moving in the atmosphere. Bless you. Bless you. So these arrows, energy enters the system, but energy can also leave the system. See this arrow here? It could be leaving the Earth's atmosphere. See this arrow here? It could be leaving. So energy both enters and exits the Earth system. When we are thinking about energy in the Earth system, what we really care about is the amount of energy absorbed by the surface. The energy moving through the atmosphere might look like it is in the Earth system, but this energy is traveling. It cannot affect Earth's climate until it is absorbed. The arrows only show energy entering and exiting. The yellow circles show when the surface absorbs or takes in energy. And remember, in the sim, when the surface absorbed energy, it got this glow. And you can see a little bit of a glow here. The more energy it absorbed, the brighter the glow was. But there were also little circles like that. No, those were the molecules. There were little yellow circles that showed when energy was absorbed. What can affect the amount of energy near Earth's surface? We are going to imagine 3 different tests. Daniel, can you please stop doing that? We are going to imagine. Andrew, I'm sorry. Can you please stop doing that? We are going to imagine 3 different tests about the energy entering and exiting Earth's system. You're going to highlight your answer choices below. All right, so we're just imagining. Test number 1. In this test, the energy is the same going near the Earth's surface as leaving the Earth system. What happens to the energy at Earth's surface? Did it increase, decrease, or stay the same? So this is the energy is the same going near the Earth's surface as leaving. So that would mean they're pretty balanced. They're stable. So we're going to highlight, and I forgot, we have to...
I got a cake.
What?
A cake.
No, I'm working right now. So we're going to highlight stays the same in yellow. Okay, test number 2. In this test, which you're imagining, more energy enters near Earth's surface than exit. What happens to the energy at Earth's surface? So the Earth's surface is absorbing more energy, so it's going to increase. Test number 3, we're imagining. In this test, more energy exits than enters near Earth's surface. What happens to the energy at Earth's surface? So for this one, more energy is leaving the Earth system than is being absorbed, so it would therefore decrease. Right. Make sure that you're doing that on your document. Which situation leads to an increase in temperature? The same amount of energy enters and exits, more energy enters than exits, or less energy enters than exits. Leading to an increase in temperature would be more energy enters than exits the system. Which situation leads to a decrease in temperature? Hold on, let me pause. Okay, so which situation leads to a decrease in temperature? Okay, no talking right now. So a decrease in temperature would be that less energy enters than exits. It makes sense that less energy would be entering than what is exiting. Hold on again, guys. So sorry about that. My son demands my attention whenever I'm on my computer. Okay, so your teacher will play the energy model video in her video. So I'm going to stop here with this video, and I'm going to start a new one. This ensures that it doesn't take 3 hours to load. All right, so I'm going to stop here.